Hello there everyone, I'm uxwbill. Several of my viewers have mentioned to me recently that I'm very near to reaching a significant milestone here on YouTube, the creation of my 1000th public video. Now, I am unable to independently, at least to the best of my knowledge, independently verify the authenticity of these statements, because when I go into my creator dashboard, or whatever they're calling it during this particular half hour, I see only the total number of videos that I have uploaded, including private and unlisted ones, and that number is certainly north of 1,000. I also think that my claim to uploading 1,000 videos is something of a nominal accomplishment, because there are videos that for some reason or another, mostly to do with YouTube's increasingly draconian enforcement of copyright and continued erosion of fair use, I've removed videos from my account just to avoid any potential trouble. You see, I've been on YouTube for basically 12 years now. That's an accomplishment that I'm quite proud of, and it's something that I would hate to lose over something as petty as a claimed copyright infringement, even though I have tried very hard to stay clear of those things. For these special videos leading up to my 1000th, I've decided that I'm going to revisit some projects that I started talking about a long time ago, and that ended up just being kind of forgotten. Now, before anyone gets their hopes up too high that I'm going back out to the farm and seeing the grain truck again, unfortunately that is impossible. The grain truck is long gone. I wish it hadn't played out that way, but there was nothing I could ultimately do about it. All of these videos that are celebrating this special occasion will be computer related. I'm sure that's got a number of people quite elated already, because it seems whenever I talk about computers, that's the thing that really packs the house. Today, however, we're going to be talking about uninterruptible power supplies. There are many kinds of them, many different types, some using strictly electrical means. Those are by far and away the most common. Some are electromechanical. There are many different kinds. But the thing that springs into most people's mind when they think of an uninterruptible power supply or a UPS is something like the white-colored unit sitting on top of the black Tripp Lite. And that is more accurately known as a standby or line interactive style uninterruptible power supply. In the standby topology, the inverter is typically kept completely inactive until something occurs of significant magnitude on the power line that the uninterruptible power supply's controlling logic decides to kick in and carry the load from its inverter for as long as is necessary, either for the power problem to pass or the user to effect a shutdown. You move up a little bit on the food chain and you find the so-called line interactive models of uninterruptible power supplies. These are a little bit more sophisticated. Some of them actually run their inverter all the time, but at greatly reduced capacity, and oftentimes they use it to charge their batteries, so the circuitry actually has dual purposes, which helps to save on number of components and therefore cost of the completed unit as well. A line interactive UPS also typically has the capability to adjust low or high line voltage, sometimes only one or the other, without actually having to switch over to the inverter and head for the battery, which only has limited runtime. And then there are uninterruptible power supplies like the one you see below, the black Tripp Lite, that are referred to as online or double conversion uninterruptible power supplies. And these are a horse of a different color, because they actually have only one use for the incoming AC line power, and that is to charge their batteries. When these are operating normally, everything that is plugged into them is running from the inverter all the time. This provides very effective isolation against power line events, including severe overvoltages and spikes of far too short a duration for an uninterruptible power supply to normally be able to intervene. And so it is that these things provide for very effective filtering from power line occurrences getting to the equipment that's attached to them. Most people never need that kind of high-end power filtration. In fact, these things are very uncommon. This is the first one that I have seen in basically 25 years worth of freelance computer consulting. I actually found it in a pile of stuff destined for e-waste recycling, which is odd because, as you'll see when we take a look around it here in a bit, it doesn't look like it's hardly ever been used. What motivated me to think about saving it was when I touched a button on the front panel, and even though it had been sitting in this unheated, miserably dirty warehouse for ages, it actually came on and started to initialize itself, as though the batteries in it were still good and capable of carrying a load, or at least having sufficient state of charge to let the operating logic power up. So let me go ahead and tell you all about my new toy. Without wanting to go into terrible detail for a whole bunch of different reasons, there was a lot of question initially whether or not I'd be allowed to even rescue this unit from the electronics recycling pile that I'd picked it out of. And while it did not end up being the happiest circumstance that allowed me to ultimately save it, I am glad that such was eventually the outcome. As I said in the previous segment of video, these things are not exactly common, especially in smaller sizes such as this. Most people just don't need this much power protection for their equipment. In fact, a lot of fairly large uninterruptible power supplies that you'd find in data centers are actually only of the line interactive or even rarely the standby design, because the equipment's not going to care about a little bit of delay while the thing changes over and manages to start the inverter. But being as this thing isolates its load completely from the incoming power, this thing can actually perform some very interesting tricks. And I'll demonstrate a few of those in this video, but first, let's go ahead and turn this thing on. I must not have held it long enough to get it started up. There we go. Got it then. You can see it's about to run its diagnostics. I don't know how many tests it's actually performing, but you can see the various lights in the dramatically simplified schematic of operation here have come on, indicating that it is in fact operating from normal line power right now. As with many sophisticated uninterruptible power supplies, there's a list of parameters that you can actually adjust. So we'll go into the menu right now, or at least we'll try to. You can control the output voltage. You can also control the output frequency, which means if you need this thing to act as a frequency converter, if you have a 50 hertz device that you've brought in and you need to run it on a 60 hertz electrical system, this thing can help you do that. Likewise, if you have something such as a device that runs from a nominally lower line voltage than is the standard here in the United States, where we use 120 volts AC, this thing can help you out. Now, that's not to say that you can set this thing up to give you 220 or 240 volts AC. Its range of compensation is pretty limited. I think it goes as far down as 100 volts AC and maybe as high as 130. It's certainly been a while since I have played with this, so there are a lot of things that it can do, and I may not be in the best position to ultimately explain them. As you can see, some of the parameters right now that you're looking at, there's the information about the battery system, an estimate of runtime. I don't know how old this thing is, but I am surprised, to say the least, that it was scheduled to be recycled when it still seems to work just fine, and as though it has good batteries in it. We'll take a little bit of a look at that later. But for now, let's go ahead and play with one of the capabilities that this thing offers, and that is the frequency conversion capability. It took a little bit of diddling around to make it happen, because the menus on this thing aren't exactly snappy to respond as you're navigating them. The navigation itself is a little bit clumsy, and you have to actually select more than one option to switch this thing into its frequency converter mode. But as the built-in liquid crystal display now clearly indicates, that is exactly what it's doing, and yet it's still running from the AC power line, at least as directly as it ever does. And if we go and take a look with a meter having a frequency counter, you'll see that the change is definitely taking place. Here's a multimeter that I've set up as the control for this particular demonstration or experiment. It's actually connected to the AC line power serving this building, and if we select the frequency measurement mode, you will see that a nominal 60 hertz or cycles per second frequency is indicated for the power line. And then over here I have another meter hooked up. This one represents the variable, It's actually connected to an outlet on the back of this uninterruptible power supply. There's the voltage that it's indicating. It's very precisely regulated, as you can see, by the dual conversion or online nature of this particular UPS. But much more interestingly than that, if I choose the frequency measurement mode, here again you can see that it is operating at 50 Hertz or cycles per second, alternating frequency. Get both meters in frame here so that you can see them both and be relatively assured that no shenanigans are taking place. Now, meter tests are all well and good, but I thought it might be even more interesting to actually operate something from 50 Hertz electrical power. Now, I don't actually have anything that's designed to operate at that frequency, but I figure we can probably get away with it for at least a short period of time with something like that box fan that you're looking at right now. I don't figure there'll be any lasting harm done. I always forget which way you can go with that. I know that if you go in one direction, and I think it might be running a 50 Hertz motor on 60 Hertz power, that it might overheat. I probably have that backwards though. I'm sure somebody will correct me about that in the comments, and as always, I do welcome gentle corrections and amplifications, because as much as I try to get everything right, I'm only human, my brain is full, and sometimes I do in fact make some mistakes. So let's just see what happens. Of course, it has to be said that not every motor is dependent on line frequency for establishing its rotational speed, but simple induction motors typically do work in that fashion. And we'll do an A-B comparison so you can see the difference and hear it too. Here's the box fan all hooked up and ready to go. Let's just turn it on and listen to what it sounds like. And now back to 60 Hertz. I'm sure that you probably noticed in the previous segment of video how this fan made a very resonant, throaty, and definitely rather unhappy sounding noise when it was running from 50 Hertz alternating current. I'm not sure exactly why that may have been. I really would not expect the motor windings to be capable of producing that much noise. It is entirely possible that whatever noise they did make just happened to be at this cabinet's resonant frequency and thus was greatly amplified by it. I'd also have to wonder, although I'm not enough of an electrical engineer to know this, I'm not really an electrical engineer at all, I'd wonder if at the lower line frequency, if the rotating magnetic field inside the motor, instead of keeping it advancing smoothly, was actually causing it to fight against itself in order to stay running, thus causing the production of that exceptionally unhappy noise. Now that we've returned to the proper line frequency, I'm sure that you've noticed how smoothly and quietly this fan ran. That's because, as you would expect, this uninterruptible power supply's inverter has a true sine wave output characteristic. I'm not sure where my scope meter is, so you're probably just going to have to trust me when I say that because of this thing's role as a high-end power protection device, that its output waveform is in all probability better than even the best utility power out there. That's its job. It's got to protect the equipment to which it's attached. Here again, I've hauled the 2 meters out to demonstrate the voltage adjustment capability of this UPS. This again is connected to the line power provided by the building and the power grid, and the clamp meter is attached to the output of the UPS. So too is the box fan, so we'll just go ahead and have a little run up here. It's running at the right frequency now, but the wrong voltage. And you'll see that too also affects the rotational speed of this motor. Voltage adjustment can also be performed in the other direction up to a maximum of about 130 volts AC. And now here we are at the maximum of the uninterruptible power supply's output voltage capability. My line voltage around here actually tracks a little bit toward the high side, so the difference is not as profound as at first it would seem. And here again is the box fan. Finally, here's a nominal line voltage setting, 115 volts AC, and although it will make little to no difference in the operational characteristics of the fan, we'll go ahead and spin it up just for the sake of being thorough. Maybe it's spun up a little slower, but who can really say for sure? Unless you sit there and clock it with a stopwatch. And I'm not really sad enough to do that, even as many details as I choose to focus on. So there you have it. Those are the two major claims to fame of this Tripp Lite Smart Online 1.5 kilovolt ampere UPS. Of course, it functions perfectly well as a conventional uninterruptible power supply too. I'll demonstrate that next. We'll see whether or not the batteries in this thing are actually good. But I think they'd have to be. Now let's pretend that the keykeeper was driving around the big brown piece of junk and oops, all of a sudden the brakes went out and he hit a power pole. I'd certainly hope that never happens because it's a very hazardous situation. In fact, I wouldn't wish that on anybody, but like I said, we're just pretending. There you go. Switched over to battery absolutely flawlessly. The fan still sounds great, as well it should. So let's go ahead and switch back over to line power. We'll do it again. Because maybe he took the even bigger green piece of junk out to rescue the big brown piece of junk. I'll find out whether or not he's watching. I'm sure he'll leave a snarky comment for me. I have noticed that this thing makes an interesting noise even though it's already powered up, but the power to its built-in outlets is shut off. When you turn them on, somewhere along the way as it performs its self-tests, it makes kind of an interesting muted squeaking noise. It almost sounds like a slightly squeaky disc brake on a car. I have no idea if the camcorder will pick it up, but I'll go ahead and turn it on and we'll find out. I'll just try putting this thing a little bit closer. So if it does make the noise, as I'm sure it will, and the camera actually picks it up, and neither my video editor nor YouTube's audio recompression processes perform any kind of a band pass or band blocking filter on it that eliminates the noise, maybe you'll actually get to hear it. There's one of them. Sometimes it makes a second one, but it didn't this time. Tripp Lite claims that this thing has a transformerless design, which probably means that if it ever broke down, it's positively nasty to troubleshoot and work on. In other words, you're probably just better off replacing it with another one. Although I would imagine that if you went searching for one of these on the second-hand market, you would find that it was rather excitingly expensive. This is what the output waveform happens to look like. Take a closer look at it here. And that's at 60 Hertz or cycles per second. And that is at 50 Hertz or cycles per second. This is the battery pack. I believe it not only to be the original factory supplied pack, but I also believe that all of the original batteries are still in it and that it has not been rebuilt. It is certainly possible, depending upon how old this thing actually is, that someone could have changed this out for a replacement Tripp Lite manufactured and approved battery pack, but I don't believe that has actually taken place. I tried to find a date code stamped into the top of these batteries so I could make an educated guess as to just how old this thing actually is, but if there's one there, I certainly can't see it, and I'm not so dedicated as to go tearing this thing apart right now. This is a nominally 48 volt system. That's 4 12 volt batteries in series with one another. And here's where you make the connection to the rest of the UPS. This little door is actually a nice touch to provide some additional protection for this connection point. I wonder how many of those got broken off during these things' normal service life due to rough and rude treatment from people who were in a hurry to get their batteries changed out. The batteries look to be in good shape. They're not in any way bloated or misshapen, and they're certainly still capable of holding a charge. And here's something that American Power Conversion could definitely learn from, although I believe they have with their new generation of smart UPS products. The cabling to the front panel is actually made to be detached, so unless you're very, very careless, you won't end up ripping the cable off of the circuit board at either of the points where it connects. If you have one of these units but don't have the matching battery pack that goes with it, here's the information that you need in order to get one, or something that is compatible at least. Here are the various informational labels on the top of the UPS with the model number, the voltage specifications, country of manufacture, some other pieces of information, and a whole sheaf of cautions about electrical shock and dealing with lead-acid batteries safely. If you want to read any of those, and I can't imagine that you do, well, you can pause the video and do so to your heart's content. Even if you happen to speak the other language on here, which I believe is in French. I haven't looked at it that closely, because what we really care about is right here on the back panel. There are a total of 6 outlets, which seems a little minimal for a beefy unit like this. Circuit breaker for protection from overloads. It looks like these outlets can actually be controlled separately, which is a nice touch. So if you wanted to have, say, load 1 turned on and load 2 turned off, or the other way around, you could probably do that. I haven't actually managed to find an exact manual for this model on Tripp Lite's website, so I'm speaking basically by making educated guesses rather than backing anything up with concrete evidence. There's a cooling opening in the back. There's really not a whole lot of ventilation on this thing, but maybe it doesn't require that. Maybe it's efficient enough that's not a problem. You do get some phone and data line protection. I'm a little surprised to see that, because I always think of that as being kind of a hokey thing, and given that this is intended to be rack mounted, you probably want more than one of those. I guess you could use it for where the equipment for your communications and connectivity comes into your building at the point of the demarc or whatnot. There's the model and serial number, and if anybody can get a year and week or month of manufacture out of that, well, you're a better man than I, although I would wonder if this 1007 here is not an indication of when this thing was made. 2010, 7th week perhaps? That would be a really good lifetime for those batteries, if they're original. Speaking of batteries, you can connect an external battery to this thing for increased runtime. There's an emergency power off connection. It's used for the big red button that you sometimes see in computer rooms, industrial process areas, data centers. You also get not only universal serial bus communication, but also RS-232 serial, and it looks like there are provisions for a network management card as well that I might very well try to find, because let's just say that as good a condition as this thing is in and as functional as it seems to be, yeah, this is a keeper. The gods of e-waste have truly smiled on me. Of course, the other ones, the ones that think my life is a comedy, they'll smite me down soon enough. This thing will probably blow up. Thank you as always for watching, and please do feel free to leave a constructive comment if you happen to have one.